Okay, so now let's move on to the second question. So if you are coming from the previous video, I hope you liked the previous one, and I also hope that you liked, shared, and also subscribed if you haven't, and also followed us if you haven't. So now we are having this part 2 of this, which we are dealing with a question also on probability, right? As you can see, this question I've shown here. So it is saying events A and B and C are such that A and B are independent. So A and B are independent, B and C are independent, and A and C are mutually exclusive. And we are given that the probability of A is equals to 0.3, the probability of B is equals to 0.4, and lastly our probability of C is equals to 0.2. And they said calculate the probabilities of the following events to occur, right? So the first question, they said what is the probability of both A and C? The probability of both A and C. So probability of A and C. So we are told that A and C are mutually exclusive. So if events are mutually exclusive, it means that they are not having anything in common like that, right? So it means that our probability of A and C becomes 0, like that. Let's move on to the second question. So every time you're asked what is the probability of A and B, if they're mutually exclusive, it means that the probability is just 0. So now they said what is the probability that both B and C to occur? So for probabilities of B and C to occur, it means that we are looking for the probability of B and C. But we are told that B and C are independent. So if B and C are independent, it means that the probability of B and C to occur will be equal to the probability of B multiplied by the probability of C. So for two events that are mutually that are independent, we just multiply their probabilities to find the probability of B and C, right? So the probability of B being 0.4 and the probability of C being 0.2, it means that the probability of B and C becomes 0.08, like that. And now let's move on to the last one. So they said what is the probability that at least one of A or B will occur, right? So it means that now we are looking for the probability of B or C, the probability of B or C, right? But we cannot find the probability of they said A and B, sorry. So we cannot find the probability of A and B without finding the probability of, we cannot find the probability of A or B without finding the probability of A and B first, right? And we are told that A and B, they are independent. So it means that the probability of A and B becomes the probability of A multiplied the probability of B. And A being 0.3 multiplied by 0.4, and you get 0.12. So this is the probability of A and B. So now we are trying to find A or B. So we can now say the probability of A or B will be equal to the probability of A plus the probability of B minus the probability of A and B, just like that. So now what do we have as our values? We are having the probability of A being 0.3 3, of B 0.4, and then minus 0.12. So we are going to have 0.7 minus 0.12, which we are just going to have our probability of A or B the same as 0.58, like that. So that's how you can work around the probabilities, right? If you have enjoyed watching this, please subscribe. If you haven't, please follow us. If you haven't, please like, share, and comment what you think so that we can improve our work, right? Having said that, see you on the next one, day 16. Enjoy the rest of the day.